Okay, this is part review for quiz on 32.1 through 33.2. Vectors, complex polars, oh my. Here we go. We have vector P with its tail at 4, 8. So we're going to draw this as we're doing it. The vector has a tail at 4, 8. So let's graph that. 4, 8. That's the tail. And its head.
On tests, would we have to have it in the radical form?
Probably. Or I might give you a bonus point if it's in radical form. If it's not a unit circle value, then decimal's going to be okay. And then your head is at -3, 1. And we're going to connect this tail to head. We've got, we always go, when we're writing the component form of P, you always want to do tip minus tail on your coordinates. Tip minus tail. So you're starting with your x's. Tip is -3. Tail is 4. So if you don't understand tip and tail, it's the end one. Subtract the beginning one. Okay, and then you have 1 minus 8 for a -7, -7. That is the component form for vector P. How else could we do that? We could count. So you're here. Oops, I'm sorry. You probably had to do this first. You had to go left 7 and then down 7. Left 7, down 7. So it's -7, -7. So what is absolute value of vector P? That means the magnitude. So to get the magnitude, we're going to take 7 squared plus 7 squared. Now it's really -7, right? But I don't really put the negatives in because this is 49 and 49, which is square root of 98, which is 7 radical 2. And that's your answer. So our m and n equal vector m, so -3, 2 is right here. So it's got horizontal and vertical components, -3, 2. It is going north of west. The other one is going to be down here. It has the same magnitude. Like if you did 3 squared and 2 squared, it has the same magnitude, but it doesn't have the same direction. So this answer is no. Same magnitude, but different direction. That's why. So A, add these symbolically. So we're going to plot 2, 5 from standard position. 2, 3, 4, 5. And then we're going to connect the tip of this to the tail of the second one, which the second one is -5, -3. So let's label this one S. So T is left 5, down 3. So we're going to draw this one. That is T. And this is your answer right here. So this is S plus T. So graphically, it looks like my answer should be -3 and 2. So it looks like -3 and 2 are the horizontal and vertical components. And that's what you get when you add. Now symbolically, you might have an easier time symbolically than geometrically. Because all you have to do is add your x's, comma, and then add your y's. So it is -3 and 2. So 4. I'm going to do symbolically first. -1, 7. 3, -5. But we're subtracting the sign, so this means additive inverse. We're going to distribute the negative. If you add your x's, you're going to get -4. If you add your y's, you get 12. So your vector diagram, your triangle should end at -4, 12. So let's just do that. -4, It's going to end about right there. So first we're going to graph negative 1, 7. Find that origin. Negative 1, 7. So that's B. And then from here we're going to go 3, negative 5. Oops, and we're not going to go 3, negative 5. We're going to go negative 3, 5 because remember the additive inverse? So we're going to go left 3, up 5. So it's going to be up here. And that's W. And then this one right here is V minus W. So that is a triangle. It's kind of hard to tell, but this is a triangle. Oops. Good God. It's supposed to be a triangle. Write 3u in symbolic form. So geometrically, okay, symbolic form would be 3 times negative 2, 3, which is negative 6, 9. And graphing it, you would go negative 2, 3. That's the first one. There are 3 of these. So you go negative 2, 3 for the second one. And negative 2, 3 for the third one. So we have U, U, U for a 3U. So notice it ends at negative 6, 9. So 6. I didn't give this to you guys. Let's just go ahead and do a tail at 4, negative 2. And let's do a tip at negative 2, 3 looks like. Let's draw this. So 4, negative 2 is here, and negative 2, 3 is right here. So let's just say I gave you this vector. Maybe I didn't give you the ordered pairs, but I just gave you the vector. And I said, compute the magnitude and direction of this angle. So I like to draw on that like a little x and y axis where the tail is, like this. So basically you can see that this angle is shooting out into the second quadrant from this little, my imaginary x and y axis right here. Shooting into the second quadrant. So the magnitude then, if you extended this, it's going to be the horizontal and the vertical. So you can either count 1, 2, 3, 4, 5, 6 for negative 6. And your vertical will be 1, 2, 3, 4, 5. Or you could have subtracted tip, negative 2 minus 4, and 3 minus 2 for a negative 6 and 5. So you could have done tip minus tail. Either way, you can either count or you can do the math for it. It's negative 6, 5. So the magnitude of this is 6 squared and 5 squared, which is 36 and 25, which is 61. The direction is arctangent of 5 over 6 in the second quadrant. $39.8 in the second quadrant. So you're going to take 180 minus that for 140.2. Or you can say 39.8 degrees north of west. I'll accept either answer. Yep. So negative 3, 5. This is going to be in standard position. 1, 2, 3, 4, 5. There's only one given, so it's always in standard position if you're given 1. And they want the magnitude. So the horizontal component is negative 3. The vertical component is 5. So its magnitude is 3 squared and 5 squared, which is 9 and 25, or 34. So that's your magnitude. And the angle would be arctangent of 5 over 3. But again, this is in the second quadrant. So arctan of 5 over 3 is 59. So you could say 59 degrees north of west. Or take 180 minus 59 for 121. Either one. 8, the magnitude is 10, and the direction is 210. So 210 is about right here. Magnitude is 10. Resolving into vectors means that you can take, so this is, you can use 210, say 10 cosine of 210, 10 sine of 210. If I wanted exact answers, this is a unit circle number. So 210 is a 30-degree angle. It's in the third quadrant, so it's negative. Radical 3 over 2, negative 1/2. So it's negative 5 radical 3 and negative 5. And number 9. Oh, if you did that on the calculator, let's see, what would it be on the calculator? 10 cosine 210. Negative 8.66. And then 10 times negative 5, that should be negative 5. So this is what it looks like as a decimal. Okay, A has a magnitude of 5 and a direction of 62. Oops, I forgot. We're going to, well, I could draw this picture. 62 is about right here, magnitude of 5. And B has a magnitude of 8, a direction of 240. So if you did a little x and y axis, 240 is going to be like probably in the same spot. Magnitude of 8. It should be in the third quadrant. That's weird, so I think I'd rather have a chart. So east, A. Vector A is magnitude of 5, direction of 62. So it's 5 cosine 62, 5 sine of 62. B has a magnitude of 8, angle of 240. And they ask us to add these. So we have 5 cosine 62 plus 8 cosine 240. That's a negative 1.653. Then we have 55. Is that 5? Oh, it says 5, sorry. 5 sine of 62 plus 8 sine of 240. Negative 2.513. So if you did a redraw, I sometimes do a redraw with these, it's going to be in the third quadrant, okay, because it's negative, negative. No, we're finishing the review in that homework 43-48 on page 462. So let's see, the magnitude then would be the horizontal component, which I know it's negative, but when you square it's going to be positive anyway, so I don't even use a negative, and 2.513 squared.
Did you do it?
For a 3.001. The direction angle would be 2.513 and 1.653. So we're getting this 56.66. However, it's in the third quadrant. So you can say 56.66 degrees south of west, or you can say, if you got 180 to that, you can say 36 point, maybe round it, 236.7. So what does 2a minus b look like? So 2a means that you're going to double the magnitude. So when I say 2a, that means the magnitude is now going to be 10. Angle stays the same. So we have 10 and 62. So 2a means 10 cosine of 62, 10 sine of 62, because we doubled the magnitude. And then we're subtracting b. But I really just add the additive inverse of b. So what that means is, when you do an additive inverse, it means your angle. So let's see here. So basically, if you have a direction of 240, the direction of 240, it's going to be down here. Magnitude of 8. When I put in, so this is B. If I put a negative in front of that, it means you're going to go this way, 8. So what that means is you're going to take 240 minus 180 because it's straight across. So 60 is the angle that's straight across from it. So 60 is the angle we're going to use. So we're going to go 8 cosine of 60, 8 sine of 60. That's because there was a negative sign. So you have to add 180 degrees to the angle. So we have 10 cosine of 62 plus 8 cosine of 60 for an 8.6947. Okay, and then we have, how about we try this the same? Let's go a second enter, and it brings up the same thing, and we're going to put signs in instead. Sign here, sign here, and that's the same. 15.758. We do a square root, do 8.6947 squared, so it's 15.758 squared. Or 17.997, so we're going to say that's about 18 magnitude. Okay, and then the angle, these are both positive, so its first quadrant is going to be 15.758 over 8.6947. It's going to be in the first quadrant, they're both positive. Arctan, 15.758 divided by 8.6947 for a 61.1 degrees angle. But you can't see that. So there you go. Arctan of the vertical over the horizontal, 61.1.